So one of the things that happens is when we take a binomial, like for example, x plus 3, and I multiply it by a binomial 2x minus 5. When I do this multiplication, I get a new expression that is equivalent to the expression that I started with. And I want to demonstrate that using our classroom calculators. So for example, if I do this, I'm going to use a generic area model. It's going to be a 2 by 2 grid because I've got a binomial times a binomial. Across the top, when I multiply the height, I'm going to go ahead and list this as x, and then this is the plus 3. And then across the top, I have the 2x and the minus 5. Again, in order to get the area of these little individual rectangles inside, we multiply, and then to combine them, we add. So in this very top box here, I've got a 2x times an x, and when I multiply 2x times x, I get 2xx, or 2x squared. Below that, I've got a 2x times a 3. When I multiply the 2x times the 3, I get 6 times x. Over in the upper right box, I'm multiplying negative 5 times x. When I combine those, I get negative 5x. And then finally below that, I have a 3 times negative 5, which is negative 15. So I can see that I have two terms that are like terms, two terms that can be combined. This term, right, and this term. They're both just x's. So because they're both just x's, they can be combined. So my final answer, when I multiply these, I get the following. I get 2x squared. Let me write 2x squared, 2x squared. And then I've got positive 6x minus 5x, which is just going to give me a plus 1x. And then I've got minus 15. So in all cases, for any value of x that I pick to put in here, these should be equivalent, right? This thing that I'm underlining in blue should always produce the exact same outputs as this thing that I'm underlining in purple. So this is one way that I can take an expression and I can rewrite it, right? I can rewrite it using multiplication. So let's verify that this is indeed at least plausible. So I'm going to go to our classroom calculator. And what I want to do on this is I'm going to store some random value of x. I'm going to store negative 2.235. And I'm going to say that that is what x is. So what I want to demonstrate is that for this expression we have, the left-hand side and the right-hand side are always equal. So I'll clear this, and I'm going to go ahead and type on the one side I've got x plus 3. And when I close that, I get x, or 2x minus 5, 2x minus 5. And for our current value of x, that is this number, negative 7.24455. Now, that should be exactly the same as, right? It better be the same as, and that's our claim, right? This should be exactly the same as or equal to this thing. And if this doesn't produce the same negative 7.24455, they're not equal, and I've made an error somehow in my multiplication. But let's go ahead and evaluate it. So it should be the same as 2x to the second power, and then plus a single x, and then minus the number 15. And you can see as soon as I press enter, they're exactly the same. Not convinced. Look, this is not a proof that these two things are equivalent. However, it's just me helping to verify. Let's pick a different value for x. Let's say that x is 5.2315. So I'm now going to store that as x. What I love about the calculator is I don't need to retype those expressions. I can just go up and get the left-hand side. Got it. It is now this number, 44.96. And I'm going to go get the other side. And oops, there it is. Got it. And it is also the same. So I can see that one thing I can do is I can take an expression like this, right? And I can rewrite this. I can change its format so that it looks like this instead. So it's kind of a nice tool to take something that I have and rewrite it in a different format. And you're going to see at different times in your math career, sometimes you're going to want to multiply, and sometimes you're going to want to do the reverse of that. And we'll talk about that. But how do you take a sum of parts and turn it into a product of things? And that's a preview of next year. Anyways, that's it. A review of how do we multiply binomials. When we multiply binomials, what's the significance of it? Well, we're just rewriting something in a different format. They should be the same. And I always like to go back to the very simple thing. Like one way I can write the area of a rectangle that's 3 by 4, well, I can write the area as 3 times 4. That's one way to write the area. But I can also write it as 12, right? Those are two different ways of writing the same thing. 3 times 4 is always 12. And just like x plus 3 times 2x minus 5 is always 2x squared plus x minus 15.